Welcome, friend, and thank you for joining us on this journey through the mysteries of the universe. In this video, we'll explore the fascinating concept of black holes, not just as cosmic monsters, but as potential gateways to other universes. Sit back, relax, and let the vastness of the cosmos calm your mind as we venture deeper into the unknown. Chapter 1. Introduction to black holes. Black holes are among the most fascinating and mysterious phenomena in the universe. These invisible regions of space have captured the human imagination for centuries, representing the ultimate symbol of cosmic mystery. To understand the true nature of black holes, we must first explore how they form and what makes them so different from other objects in the universe. A black hole begins its life as a massive star. Stars are born from clouds of gas and dust that collapse under their own gravity. As the star undergoes nuclear fusion, it releases vast amounts of energy, which counteracts the force of gravity, trying to collapse the star in on itself. This delicate balance keeps the star stable, allowing it to shine brightly for millions or even billions of years. However, when a star runs out of fuel, it can no longer sustain this balance. The core of the star begins to collapse under the force of its own gravity, and this collapse leads to a cataclysmic explosion known as a supernova. In the most extreme cases, the core left behind is so massive that it continues to collapse even further, eventually forming a black hole. A black hole's defining feature is its event horizon, a boundary beyond which nothing, neither matter nor light, can escape. This point is called the point of no return, because once something crosses this threshold, it is trapped by the black hole's immense gravitational pull. The event horizon represents the edge of the black hole, a place where space and time become distorted in ways that we still do not fully understand. The interior of a black hole is where things get even more mysterious. At its core, there exists a region known as the Singularity, a point where gravity is so intense that space-time curves infinitely. The laws of physics as we know them cease to function in a way we can predict or comprehend. Matter is compressed into an infinitesimally small space where the density becomes infinite. This singularity lies at the very heart of every black hole and is the ultimate puzzle for physicists and astronomers. While black holes cannot be seen directly, since no light can escape their grasp, we can infer their presence by observing the effects they have on nearby objects. If a black hole is part of a binary system, it may pull matter from a companion star. As this matter spirals in toward the black hole, it heats up and emits intense radiation, which can be detected by telescopes. These glowing, spiraling disks of matter around black holes are called accretion disks, and they provide the only observable clue we have to understanding the nature of black holes. Despite their ominous reputation, black holes are not inherently destructive. They don't actively devour everything around them. In fact, many black holes lie in peaceful isolation, away from the reach of stars or planets. It's only when objects stray too close that the immense gravitational pull of a black hole becomes dangerous. Even then, it is not an immediate or violent process. For a person or spacecraft falling into a black hole, the experience would be gradual. The further you travel toward the event horizon, the slower time appears to move, as seen from an outside observer. To someone falling into the black hole, however, time would seem to continue normally. But once you cross the event horizon, you are forever lost to the black hole's grasp. While the idea of falling into a black hole may sound terrifying, it's important to remember that black holes are not scattered randomly throughout space. In fact, most black holes are located far from Earth, and those that are closer to us, such as the supermassive black hole at the center of our galaxy, are not a threat to us. In the future, however, as we continue to explore space, black holes may offer us an intriguing window into the very nature of the universe. including the mysteries of time and space itself. As we consider these strange and fascinating objects, it's essential to remember that black holes are not an end to the universe, but rather a gateway, a doorway to a deeper understanding of the cosmos. Their existence challenges our perceptions of space, time, and even reality itself. Through black holes, we are invited to think beyond the limitations of our world and into the vast unknown. Chapter 2. The Mystery of Singularities. At the core of every black hole lies a singularity, a concept so strange that it bends our understanding of physics. To describe a singularity, we must first acknowledge that it represents a point where the laws of nature, specifically general relativity, break down. A singularity is a place where gravity becomes so intense that it warps the fabric of space-time itself, creating a region where infinite density and infinite curvature of space-time exist. It is, in essence, the universe's ultimate paradox. When a star collapses into a black hole, its core compresses to an infinitely small point. This point, the singularity, has no volume, yet it contains all the mass of the original star. The forces at play within a singularity are incomprehensible. Space itself is no longer the smooth, continuous medium we are familiar with. Instead, it becomes a distorted, chaotic tangle where the usual laws of physics no longer apply in the same way. In more familiar situations, when objects are subjected to intense forces, their behavior can be described using classical mechanics or quantum mechanics. For example, when an object is accelerated, its velocity can be calculated using Newton's laws, and when tiny particles like electrons move, quantum mechanics governs their behavior. But at the singularity of a black hole, the classical and quantum descriptions of space and time collide, producing an enigmatic region where neither theory is sufficient on its own. In the context of general relativity, the singularity represents a point where the curvature of space-time becomes infinite. This suggests that space and time themselves lose their meaning in the presence of a singularity. It is as if the very structure of reality is torn apart. One of the greatest challenges for physicists is to reconcile general relativity with quantum mechanics, as these two frameworks of physics seem to conflict with each other in singularities. For instance, quantum mechanics suggests that particles cannot have infinite energy or mass, yet at the singularity, these qualities are forced to exist. This contradiction has led to the development of theories like quantum gravity, which attempts to describe gravity at quantum scales. The hope is that such a theory will one day provide a comprehensive understanding of what happens inside a black hole and resolve the mysteries surrounding singularities. Despite the theoretical understanding of singularities, the problem of observing them directly remains. A singularity itself is hidden behind the event horizon, a boundary beyond which no information can escape. The event horizon serves as a cosmic shield, preventing any light or matter from returning once it crosses this point. This makes it impossible to directly observe a singularity, leaving scientists with only indirect evidence of their existence. But through the study of black hole dynamics, gravitational waves, and the behavior of matter near black holes, scientists can begin to piece together the story of these hidden enigmas. What truly makes singularities so fascinating is their potential connection to the very fabric of the universe. In a sense, they might provide the key to understanding some of the deepest mysteries of reality. If, as some theorists suggest, a singularity can serve as a bridge between different points in space-time or even between different universes, then the study of singularities may eventually help us understand the structure of the multiverse itself. For now, singularities remain one of the most tantalizing and impenetrable aspects of modern physics. In a more peaceful sense, thinking about singularities encourages us to appreciate the inherent mystery and wonder of the universe. They remind us that there are aspects of reality far beyond our current understanding, areas of space-time that challenge our perceptions of what is possible. For all their scientific intrigue, singularities also embody the beauty of the unknown, offering a sense of awe and humility in the face of the cosmos. Chapter 3: The Event Horizon, a threshold to the unknown. The event horizon is often described as the point of no return of a black hole. It is the boundary surrounding a black hole that marks the limit beyond which nothing, not even light, can escape. For any object that crosses the event horizon, there is no way to return. It is a place where time, space, and matter are transformed in ways that defy our everyday experience of the universe. One of the most intriguing aspects of the event horizon is its relationship with time dilation, a phenomenon predicted by Einstein's theory of relativity. As an object moves closer to the event horizon, time for that object begins to slow down relative to an outside observer. This means that if you were to watch someone falling into a black hole, their movement would appear to slow down as they approached the event horizon. From their perspective, time would continue to pass normally, but to an observer far away, they would seem to freeze at the moment of crossing the event horizon. This slowing of time is a result of the extreme gravitational forces near the black hole. The curvature of space-time becomes so intense that time itself is stretched and distorted. In essence, the event horizon represents a boundary where the normal flow of time breaks down. For anyone falling into the black hole, time itself becomes irrelevant. But for an observer at a distance, it appears as if the object approaching the event horizon is frozen in time, lingering on the edge of the black hole forever. Although the event horizon marks a dramatic boundary, it is not an actual physical surface. It does not have any solid substance, but rather represents a theoretical boundary in space-time. This is why, even though we cannot see the event horizon directly, we can observe the effects it has on the surrounding space. As matter and light are drawn into a black hole, they form an accretion disk, a swirling mass of hot gas and dust that radiates energy. The accretion disk can be observed by telescopes, allowing us to detect the presence of a black hole and infer the location of its event horizon. Interestingly, while the event horizon is a barrier beyond which nothing can escape, it is also a place of intense energy and activity. As material is pulled toward the black hole, it heats up to incredibly high temperatures, emitting X-rays and gamma rays in the process. These powerful radiation bursts provide valuable insight into the nature of black holes and their surrounding environments. Despite the danger posed by the immense gravity of a black hole, the event horizon is a dynamic and active region of space, where energy and matter interact in fascinating ways. The event horizon also plays a crucial role in the study of information paradoxes. According to classical physics, once something crosses the event horizon, it is lost forever. No information can escape. However, quantum mechanics suggests that information cannot truly be destroyed, raising questions about what happens to the information swallowed by black holes. This paradox, known as the black hole information paradox, is one of the major unsolved mysteries in modern physics. It highlights the tension between the laws of general relativity and quantum mechanics, and it continues to be a subject of intense debate among physicists. For the individual falling into a black hole, crossing the event horizon would be an unimaginable experience. As the person moves closer to the black hole, they would be stretched in a process known as spaghettification, due to the difference in gravitational forces between the upper and lower parts of their body. While this would be a violent process, it is important to note that from the perspective of the person falling in, the experience would feel smooth and uninterrupted, at least until they reach the singularity. While crossing the event horizon marks the end of the journey for an object or person, it also opens the door to some of the most profound questions in physics. What happens beyond the event horizon? Is there another universe on the other side? These questions remain unanswered, but they inspire both awe and wonder in those who seek to understand the true nature of black holes. The event horizon reminds us of the infinite mystery that exists in the universe. It is a boundary that marks the unknown, a place where the rules of physics as we know them cease to apply. Yet, it is also a place of incredible beauty, where the fabric of space-time is stretched and twisted in ways that challenge our understanding of reality. As we continue to explore the cosmos, the event horizon remains one of the most intriguing and awe-inspiring phenomena we encounter. Chapter 4. Theoretical portals to other realities. The idea that black holes might act as portals to other realities stretches the boundaries of our understanding of the universe. Though it sounds like science fiction, this concept is rooted in serious scientific theories about space, time, and the fabric of reality itself. If we were to imagine black holes as gateways to other universes, we would be venturing into the realm of the multiverse, a theoretical framework that suggests the existence of multiple, possibly infinite universes beyond our own. To explore this concept, it helps to understand what a black hole is at its most basic level. Black holes are regions of space where gravity is so intense that it pulls everything inward, even light itself. The black hole's event horizon marks the boundary beyond which nothing can escape, not even the most energetic particles. This boundary symbolizes a profound change in our understanding of space and time. Inside a black hole, gravity becomes so extreme that it warps space-time to such a degree that our usual understanding of physics no longer applies. Now, imagine if black holes could serve as conduits between different universes. According to some theories, space-time is not just a single linear structure, but is instead composed of many different regions, each potentially having its own set of physical laws. These regions might exist alongside our universe, like bubbles in a vast cosmic ocean. A black hole, in this context, might act as a bridge or a wormhole, linking one universe to another, just as a tunnel might connect two different locations in space. A wormhole is a hypothetical passage through space-time that connects two distant points in the universe. The idea is that a black hole could potentially act as the entrance to this passage, leading to another point in space-time, or perhaps to an entirely different universe. If wormholes truly exist, they would allow for faster-than-light travel between these universes, bypassing the vast distances that separate galaxies. This would open up incredible possibilities, worlds with entirely different physical laws, new forms of life, and even parallel versions of our own universe. The concept of black holes as portals also ties into the broader theory of the multiverse. The multiverse suggests that our universe is just one of many, each with its own set of physical laws. Some versions of this theory propose that black holes might connect different universes, each with different constants and properties. For example, one universe might have stronger gravity, while another might have entirely different particles and forces. These universes could be connected by black holes, offering an entirely new way of understanding the cosmos. Despite its fascinating possibilities, the idea of black holes as portals is still highly speculative. There are many challenges to this concept, particularly around the stability of wormholes. A wormhole would need to remain open long enough for something to pass through, but the intense gravity of a black hole could cause the wormhole to collapse, destroying anything that tried to enter. Additionally, the strange nature of space-time inside a black hole, where matter and energy become infinitely dense, poses significant challenges to our current understanding of physics. Nonetheless, the very possibility that black holes could be gateways to other worlds is an exciting thought. It challenges our ideas about space and time and opens up new avenues of exploration. If black holes are indeed portals, then they represent one of the most profound mysteries of the universe. Perhaps in the future, we will develop the tools and understanding to explore these gateways and, in the process, uncover the nature of the multiverse itself. In contemplating black holes as portals to other realities, we are not just considering a scientific theory. We are also reflecting on the vastness of the unknown. The universe is filled with mysteries, and black holes are some of the most enigmatic objects we can study. They invite us to think beyond the limits of our understanding, to imagine what lies beyond the boundaries of our universe, and to explore the possibility that the cosmos is far more complex and interconnected than we could ever have imagined. Chapter 5: The Quantum Connection. Quantum mechanics, the field of physics that governs the behavior of particles at the smallest scales, is known for its strange and counterintuitive principles. While these ideas often defy common sense, they offer intriguing possibilities when applied to the extreme environments of black holes. Could quantum mechanics provide a pathway to understanding black holes as potential portals to other universes or dimensions? Could quantum behavior, such as particles existing in multiple states at once or instant communication across vast distances, unlock the mysteries of black holes and their role in the cosmos? To begin, consider the concept of quantum entanglement. This phenomenon occurs when two particles become linked in such a way that the state of one particle is instantly correlated with the state of the other, regardless of the distance between them. It seems as if the two particles can communicate instantaneously. In the context of black holes, could quantum entanglement help explain how information or matter might travel across the event horizon, the point beyond which nothing can escape? Some scientists theorize that black holes may not be the final trap that we once believed. Instead, they could be portals, allowing particles and possibly information to tunnel through space-time. This idea brings us to quantum tunneling, another principle in quantum mechanics. Quantum tunneling is the phenomenon where particles pass through energy barriers that they should not, according to classical physics. Could this process explain how black holes might connect our universe to another? If a particle could tunnel through the event horizon of a black hole, it might emerge into a different region of space-time, or even a different universe entirely. While we are far from proving this theory, it provides an intriguing perspective on black holes, one that sees them not as an end, but as gateways that might lead to other realms. Quantum mechanics also suggests that space-time itself is not a smooth, unchanging fabric. Instead, it is dynamic and fluid, fluctuating on the smallest scales. This concept, known as quantum foam, means that space-time at the quantum level is far from predictable. Could these fluctuations create microscopic wormholes, tiny tunnels that connect distant points in space-time? If these tiny wormholes exist, black holes might act as the macroscopic manifestations of this quantum process, offering a larger-scale passage to different dimensions or universes. The idea that a black hole might be the entrance to a completely different reality governed by different laws of physics is a mind-boggling but tantalizing possibility. While these ideas remain speculative, they invite us to think beyond the traditional understanding of black holes. Instead of viewing them simply as regions where matter is destroyed, we could begin to see them as bridges, linking different points in the cosmos, or even different realms of existence. The event horizon of a black hole could represent a boundary between dimensions, a place where the very fabric of reality itself becomes fluid and permeable. The connection between quantum mechanics and black holes is still being explored, and we have much to learn. But the potential for black holes to serve as portals to other universes invites us to view the cosmos with a sense of wonder and openness. Quantum mechanics, with its strange and mysterious behavior, could offer the key to unlocking the deepest secrets of the universe, suggesting that the black hole is not the end of the road, but a gateway to infinite possibilities. The more we understand about the quantum world, the closer we may come to grasping the true nature of black holes and the potential they hold for the future of exploration. Chapter 6. Could black holes lead to parallel universes? One of the most captivating possibilities that arises from the study of black holes is the idea that they could serve as gateways to parallel universes. The concept of parallel universes, or the multiverse, suggests that our universe may not be the only one. Instead, it could be just one of many universes, each with its own distinct characteristics, laws of physics, and perhaps even entirely different forms of life. This intriguing possibility raises the question, could black holes be the portals that connect these universes? The idea of parallel universes is deeply rooted in the foundations of quantum mechanics. At the quantum level, particles behave in ways that defy the laws of classical physics. For example, in quantum mechanics, particles can exist in multiple states at once, a phenomenon known as superposition. This suggests that reality is not fixed, but consists of a multitude of possibilities. If this is the case, could entire universes exist in parallel, each with its own version of reality? And if so, could black holes serve as bridges between these realities? In this context, black holes could act as interdimensional tunnels, providing connections between different universes. When matter is drawn into a black hole, it's pulled towards the event horizon, the point of no return. As it crosses this boundary, it might not just fall toward the black hole's singularity, but instead be transported to a different universe altogether. The idea that a black hole could serve as a gateway to another universe suggests that the fabric of space-time is far more intricate than we currently understand. In some versions of the multiverse theory, black holes are considered to be the points where these parallel universes intersect. If each universe is part of a larger multiverse, a black hole could act as a link between two universes with entirely different physical laws. For instance, one universe might have a slightly stronger gravitational force, while another might have entirely different constants, like the speed of light or the strength of electromagnetic interactions. This could result in vastly different environments and physical experiences. The idea that black holes could serve as connections to parallel universes offers a way of explaining some of the peculiarities in quantum physics. The notion of multiple simultaneous realities allows for every possible outcome of every event to occur in a separate universe. If this is true, black holes could be the conduits through which these divergent realities are connected. In a sense, each black hole might represent a doorway to an alternate version of reality where the laws of nature are different, and where the events unfolding in our universe could play out in entirely new ways. One particularly fascinating aspect of the idea of parallel universes is that it could potentially explain decisions and possibilities that we experience. In this view, every decision we make could create a new branching path in space-time, with each branch leading to a different universe. These branching paths could lead to entirely different versions of ourselves, different lives, different choices, and different outcomes. The concept of quantum branching suggests that every possible outcome of an event creates a new universe where that outcome plays out. Thus, black holes might be the intersections of these branching paths, where alternate realities meet. The theory of parallel universes also invites us to consider the nature of our own existence. Could there be an alternate version of Earth where life evolved differently? Perhaps there's a universe where humans never left the planet, or one where technology advanced in entirely different directions. Maybe there's even a universe where we made different choices at crucial moments in history. If black holes are indeed connected to parallel universes, they offer an almost infinite variety of possibilities for what could exist beyond our own experience of reality. Despite the compelling nature of this idea, it remains speculative. The scientific evidence to support the notion that black holes are linked to parallel universes is still lacking. However, the mathematics that govern black holes and the behavior of space-time do provide some theoretical support for the possibility of these connections. The idea of black holes acting as portals between universes is a concept that has sparked the imagination of scientists and theorists alike. Even if we may never be able to directly observe parallel universes, the idea challenges our conventional understanding of reality. It forces us to think about the universe not as a singular, isolated system, but as part of a vast, interconnected network of realities. If parallel universes exist, and if black holes serve as the gateways between them, then the universe is far more intricate and complex than we can currently comprehend. This realization invites us to keep an open mind and to continue exploring the mysteries of space and time. In the end, the idea that black holes might lead to parallel universes serves as a reminder of the boundless potential for discovery that still lies ahead. While we cannot yet explore these other worlds, the very possibility of their existence provides a glimpse into the infinite potential that the universe may hold. And perhaps in the future, as our understanding of black holes and the laws of physics continues to evolve, we will find new ways to peer into these alternate realities and uncover the secrets they hold. Chapter 7. The Infinite Journey Through a Black Hole. Imagine falling toward a black hole, an immense, invisible force that draws you in with an intensity that nothing can resist. The event horizon looms ahead, that critical point beyond which nothing can return. It's the boundary between the known and the unknown, the end of the journey, or perhaps the beginning of something entirely different. As you approach this cosmic threshold, time seems to slow down, and space itself stretches and distorts. But what would it feel like to actually fall into a black hole? What happens when you pass the point of no return? The experience of crossing the event horizon is a personal journey unlike any other. From an outside observer's perspective, you would appear to freeze in time, becoming an eternal moment at the event horizon, never truly crossing it. But from your own perspective, time flows as it always has. As you fall into the black hole, the very concept of time and space becomes fluid, distorted, and difficult to grasp. The closer you get to the singularity, the heart of the black hole, the stronger the gravitational forces become, and space-time itself is warped beyond recognition. This is where the concept of spaghettification comes into play. As you near the singularity, the difference in gravitational pull between your head and feet would stretch you out into a long, thin shape. It's a surreal experience, where the forces of gravity distort not just your body, but the very fabric of reality around you. The stretching of space-time means that the universe as you know it, your sense of direction, time, and place, begins to break down. The outside world, if it could still be perceived, becomes more distant and unreal, fading away like a dream. Yet, despite the intense forces and the terrifying unknown that lies ahead, there is something deeply calming about this journey. We're in this paradoxical passage through the black hole. You are no longer bound by the limits of the known universe. Time, as we understand it, no longer operates normally. Space itself may be bent and folded into unimaginable configurations. But within this paradox, there is a quiet beauty, a sense that in this journey, you are transcending the ordinary, entering a realm beyond. What happens as you fall deeper into the singularity is something that science cannot yet fully explain. Some theories suggest that you might emerge into a different universe, where the rules of physics differ. Perhaps this is where black holes act as the gateways to infinite realms, opening doors to new worlds beyond the limits of our understanding. The fall into the black hole, far from being an end, could be the beginning of an eternal journey, an exploration of infinite possibilities. As you descend into the black hole, you are not just experiencing spatial and temporal distortion. You are embarking on an eternal journey across dimensions, where time itself loses its grip. The paradox of falling into a black hole is that it is both the end and the beginning. It may be the final moment of one reality, but it could also be the first step into an infinite series of others. What happens beyond the event horizon remains a mystery. But the peaceful possibility that black holes are the eternal gateways to endless dimensions suggests that our understanding of existence is far from complete. In this timeless journey through the black hole, we may ultimately discover that the universe is not a singular, isolated reality, but a vast, interconnected web of possibilities, each black hole serving as a conduit to a different universe, a different experience, a different reality. As you fall toward the singularity, you are not just entering the end of one world, but stepping into the unknown, into infinite realms of existence. Chapter 8. The End of the Beginning. How could a white hole birth a new universe? Imagine a black hole, that most mysterious and seemingly destructive force in the universe. But what if it is not just the end of the road, but the beginning of something entirely new? What if black holes could be the birthplaces of entire universes, each with its own laws of physics, new stars and planets, teeming with possibilities we can't yet fathom? This concept suggests that black holes could serve as the cosmic rebirth of reality itself, giving rise to new realms after the collapse of their predecessors. While black holes are traditionally seen as devouring everything that crosses their event horizon, stars, gas, even light, another possibility exists. What if white holes, theoretical counterparts to black holes, represent the opposite force? A white hole is a region of space-time that would expel matter rather than absorb it, offering a fascinating, albeit speculative concept. Could black holes act as the seeds of new universes? A white hole, if it exists, could be the other side of the coin, where a black hole pulls everything in, a white hole pushes everything out. In this context, when a black hole reaches its singularity, it could release matter and energy that forms the foundation of a new universe. Instead of being destroyed, everything drawn into the black hole might be reborn elsewhere, triggering a big bang that gives rise to a universe with completely different properties and physical laws. The idea that each black hole could be a cosmic seed for a new universe presents a comforting vision of the universe as not a finite single existence, but part of an endless cycle of birth, death, and rebirth. In this model, the destruction of a black hole is not the end but a necessary part of the continuous cycle of creation. When one universe collapses into a black hole, it might simply be giving birth to another, much like a star that explodes and forms new stars, or a tree whose seeds grow into new life. These cosmic cycles remind us that existence is not a single isolated event, but part of an ongoing, interconnected process. Theories of quantum mechanics and relativity suggest that the conditions inside a black hole might mirror those of the early universe. Thus, black holes could act as portals through which new universes emerge, with their own laws of physics that may differ dramatically from our own. A black hole may not destroy everything it consumes, but rather recycle the universe itself, leading to a fresh beginning. While the idea of black holes birthing new universes remains speculative, it presents a more optimistic view of black holes. Rather than being symbols of finality and destruction, they could be seen as cosmic gates that initiate the next phase of existence. It's a thought-provoking concept that challenges our understanding of time, space, and the universe's true nature. In this view, the death of a star, its collapse into a black hole, and its ultimate transformation into a new universe could be seen as part of a grand, eternal cycle of existence. In a sense, black holes are not the end of the road, but the start of new, unimaginable possibilities. Universes waiting to unfold, filled with new mysteries for us to explore. Chapter 9. The Multiverse and its Implications. The idea of the multiverse, the notion that multiple universes exist, each with its own distinct laws of physics, has fascinated physicists and philosophers for decades. This concept takes us beyond the confines of our own universe, suggesting that what we perceive as reality is just one of many parallel realms, each with its own version of existence. Could black holes, as some theories propose, serve as the gateways to these parallel worlds, offering us a glimpse into the vastness of the cosmos and its infinite possibilities? Multiverse theories come in many forms, each proposing different ways in which multiple universes might coexist. One popular model is the bubble universe theory, which suggests that our universe is just one of many bubbles floating in a vast cosmic foam. These bubbles could have different physical constants, meaning that in one universe, gravity might be stronger or weaker, or the laws of thermodynamics might operate differently. If black holes are indeed portals to other realities, each one could lead to an entirely new universe with its own unique rules, stars, and matter. Another interpretation of the multiverse comes from quantum mechanics, specifically the many worlds interpretation. This theory posits that every quantum event, the flip of a coin, the movement of particles, creates a branching reality where every possible outcome exists in its own universe. If this is true, then each black hole could represent a transition point, a place where multiple branches of reality intersect and potentially merge. A black hole could serve as the threshold between these parallel worlds, offering access to countless versions of existence. While the idea of multiple universes may seem abstract, it opens up intriguing possibilities for our place in the cosmos. The multiverse theory suggests that our reality, with all its complexity and wonder, is just one of infinitely many universes, each with its own set of conditions and histories. The thought that our universe might simply be one thread in a vast, interconnected web of realities offers a peaceful acceptance of the unfathomable, that there is more to existence than we can ever fully comprehend. In the context of black holes, the idea that each one could lead to a different universe creates a deeply comforting perspective. Rather than feeling isolated in a single static reality, we can imagine that there are infinite possibilities waiting to be explored. Perhaps in another universe, a version of ourselves is living a life we might never have imagined, in a world where the laws of nature are completely different. This idea invites us to explore limitless possibilities, where the boundaries of existence are only limited by our imagination. While the scientific evidence for the multiverse is still lacking, the theory invites us to think beyond the constraints of our own universe. It suggests that black holes might not just be the final destinations of collapsing stars, but the entrances to an infinite number of realms, each offering unique experiences, histories, and forms of life. This idea offers a beautiful cosmic perspective, one that views existence as a vast, interconnected system, where each possibility is realized in a different world, offering us infinite opportunities for discovery and exploration. Chapter 10. The Infinite Possibilities of a New Universe. The concept of a new universe being born inside a black hole is one of the most mind-bending ideas in modern cosmology. Could black holes be the cosmic seeds of new realities, where each one gives rise to an entirely different universe with its own set of rules and constants? The possibilities are infinite, and this speculative idea challenges us to rethink the nature of the universe and our place within it. The multiverse theory suggests that our universe might not be the only one. Instead, there could be countless other universes, each with its own set of physical laws, constants, and histories. These universes could exist in parallel to ours, entirely separate but connected through a vast cosmic network. If black holes serve as the gateways to these universes, then every black hole could represent a unique branching reality, a separate universe waiting to unfold. Imagine that every time a black hole forms, it creates a new universe, one that evolves according to its own set of rules. Just as our universe began with the Big Bang, a black hole might serve as the catalyst for a new explosion of creation, leading to the formation of new galaxies, stars, and planets. The possibilities for life in these universes are endless. In some, life might exist in forms radically different from anything we could imagine, while in others, the conditions might mirror our own, creating parallel versions of Earth, where different decisions and events lead to alternate outcomes. The idea that every black hole could give rise to a different universe opens up the comforting thought that the universe is not a singular, isolated reality. Instead, it is part of an infinite cycle, where black holes are the starting points for new worlds, each with its own version of existence. The universe as we know it might be just one branch in an ever-expanding cosmic tree, each branch offering new and unique experiences. This could mean that every possibility that ever existed, every potential outcome, has its own universe, unfolding somewhere in the vastness of the cosmos. This infinite potential raises fascinating questions about the nature of reality. If each black hole leads to a new universe, then our reality might be just one fragment of a much larger, infinite structure. The very idea that the universe we live in could be just one of countless others invites us to embrace the mystery and complexity of existence. It suggests that our universe, with all its stars, galaxies, and life forms, is part of an interconnected cosmic web of infinite possibilities. The comfort in this idea lies in its endless variation. If there are infinite universes, then there are infinite chances for discovery, growth, and change. Perhaps in one universe, humanity discovered faster-than-light travel, while in another, intelligent life evolved under completely different physical laws. In yet another, life might have evolved without the need for carbon, giving rise to forms of existence we can barely conceive. The multiverse offers an opportunity to imagine a universe where anything is possible, a realm where the only limit is the boundless creativity of existence. The idea that each black hole could give birth to a new universe reminds us that life and creation are never finite. The universe is an ongoing process, constantly evolving and expanding, with each new universe offering a fresh start, a new version of reality where anything can happen. Whether or not we can ever travel between these universes remains a question for the future. But the idea that we are part of something infinitely vast gives us a new sense of perspective on our place in the cosmos. As we look out into the night sky and ponder the mysteries of the universe, we are reminded that the cosmos is full of infinite possibilities, waiting to be discovered. Each black hole might be the beginning of a new universe, a new reality, a new adventure. Whether we will ever explore these other realms remains uncertain, but the very thought that they exist out there in the vastness of space is enough to inspire awe and wonder in all of us. Chapter 11. Could black holes be a gateway to eternity? Black holes, often seen as the universe's most mysterious and destructive entities, may hold more than just the promise of cosmic destruction. They might also serve as gateways to eternity, offering a passage to realms beyond our understanding of time, space, and reality itself. Could black holes provide an eternal journey, where time as we know it is altered and the boundaries between dimensions dissolve? These cosmic objects, whose gravitational pull is so intense that not even light can escape, may in fact serve as timeless portals, transporting matter and energy to regions of space-time where our conventional laws break down. The event horizon of a black hole marks the boundary beyond which nothing can return. This event horizon is often perceived as the point of no return, a place where time and space are stretched to their limits, and all that falls within is doomed to an eventual collision with the singularity, the heart of the black hole, where gravity becomes infinite. However, what if this very event horizon is not the end of the journey, but the beginning of something greater? Once inside the event horizon, time behaves in ways we can hardly imagine. According to the theory of time dilation, time slows down as an object approaches the event horizon. To an outside observer, it would appear as though the object freezes at the boundary, never quite crossing it. But from the object's perspective, time continues at its normal pace, and it might experience the journey into the black hole as a fluid, timeless passage into unknown realms. This paradox raises the possibility that the experience inside the black hole could be one of eternal exploration, where the conventional flow of time is irrelevant, and the traveler is free to journey through the cosmos for eternity. But what happens once an object crosses the event horizon? Some theories suggest that black holes are not just destroyers, but potential passageways into other dimensions or even other universes. If black holes are connected to alternate realms, then the singularity at the center of the black hole could be the key to unlocking these portals. Perhaps black holes do not simply consume, but serve as doorways to endless realms, allowing a timeless journey through dimensions where the laws of physics as we know them do not apply. In this scenario, black holes become gateways to eternity, where the journey does not end but instead continues across infinite dimensions. This concept challenges our conventional understanding of the universe and invites us to imagine a cosmic network of realms, each more wondrous and mysterious than the last. Instead of a final, destructive collapse, the black hole could be viewed as a transition to a new realm of existence, a place where time, space, and the very essence of reality become fluid, allowing for an eternal exploration of infinite possibilities. The idea of black holes as gateways to eternity offers a comforting perspective on the nature of the universe. It suggests that death and destruction are not ultimate endpoints, but are simply part of a larger, ongoing cycle, a cycle in which black holes serve as the portal to new realities. This theory invites us to consider the universe as not a single, isolated reality, but as part of an endless series of journeys, where every black hole offers the chance to embark on a new, eternal adventure through the cosmos. In this timeless journey through the black hole, we may discover that the universe itself is far more expansive than we can imagine, a vast and interconnected network of realms awaiting exploration. The idea that black holes could serve as gateways to eternity not only transforms our understanding of these cosmic objects, but also expands our view of time, space, and reality itself. Black holes, far from being destructive, may offer the eternal opportunity to explore the infinite mysteries of the universe and beyond. Chapter 12. Conclusion. The peaceful paradox of black holes and parallel universes. As we conclude our journey through the vast and mysterious realm of black holes, we are faced with a paradox that is as peaceful as it is profound. Black holes, often seen as harbingers of destruction, might also be the gateways to infinite creation. These cosmic entities, which can swallow entire stars and planets, may serve as the starting points for new universes, where every possibility can unfold in parallel realities, each with its own set of laws and dimensions. The peaceful paradox of black holes and parallel universes invites us to embrace the unknown and accept the infinite potential of existence. Throughout this exploration, we've seen how black holes might act not just as cosmic vacuum cleaners, but as creators of new realms, giving birth to parallel universes through their event horizons. This view of black holes as portals to other realities challenges our conventional understanding of space and time, offering a more hopeful perspective of the cosmos. Instead of seeing the universe as a singular, isolated entity, the multiverse theory suggests that our reality could be just one of many, each universe existing side by side, each following its own unique timeline and laws of nature. The implications of the multiverse theory are profound. If black holes serve as the gateways to these parallel realms, then each one could represent a new version of reality, where every possible outcome of every event has unfolded in its own universe. Imagine a world where the laws of gravity differ, where the speed of light is not constant, or where time flows in a completely different way. The possibilities are endless, and the comforting thought that every possibility exists somewhere in the cosmos provides a sense of peace amid the chaos of our own universe. This perspective on black holes invites us to think of the universe as a vast, interconnected web of realities, where every black hole is a transitional point, leading us from one version of existence to another. The idea that black holes and parallel universes are interconnected offers a more optimistic view of the universe, suggesting that there is no final end, but rather an eternal journey through an infinite number of realms. It's as if the universe itself is a continuing story, one that never truly ends, but keeps branching out into new worlds and new possibilities. As we reflect on the mysteries of black holes, we are reminded of the paradox they present. They are both the end of one reality and the beginning of another. Each black hole might represent the convergence of infinite possibilities, where the boundaries between space, time, and reality itself become fluid. Instead of fearing the unknown, we are invited to embrace the infinite potential that black holes offer. They are not just the end of the road, but the gateways to an endless cosmic journey. In the end, the peaceful paradox of black holes and parallel universes is a reminder that the universe is far more expansive and interconnected than we can fully comprehend. Whether we ever discover the true nature of black holes or prove the existence of parallel universes, the idea that there are infinite realities awaiting exploration invites us to dream, wonder, and seek out the endless mysteries that the cosmos holds. Epilogue: Calm sleep among the stars. As we come to the end of this peaceful journey through the mysteries of black holes and their potential as portals to other realities, take a moment to reflect on the vastness of the cosmos. The universe is so much more than what we can see, feel, or touch. It is an endless, ever-expanding web of possibilities, full of beauty, wonder, and infinite realms waiting to be discovered. In this vast expanse, black holes, once thought of as destructive forces, have revealed themselves to be something far more profound. They are gateways, not just to darkness and nothingness, but to new universes, new beginnings, and infinite journeys. They remind us that even in the most mysterious and seemingly chaotic corners of the universe, there is a profound order, a cycle of creation and destruction that we can only begin to understand. Every black hole, with its infinite gravitational pull, is not merely an end, but a potential new beginning, offering access to infinite realms of possibility, where every universe unfolds in its own unique way. As you drift deeper into your thoughts and allow your body to relax completely, imagine yourself floating peacefully among the stars. Visualize the endless expanse of the cosmos, with its soft glow of distant suns and swirling nebulae. Feel the coolness of space around you, comforting and vast, like a gentle cosmic embrace that holds you safely within its vastness. In this moment, you are a part of everything: the stars, the galaxies, and the black holes, each of them existing in perfect harmony, all connected in a cosmic dance. Breathe deeply in and out, and with each breath, feel yourself sinking deeper into a state of calm. Let go of any worries, fears, or stress as they float away, lost in the gentle currents of space. You are surrounded by the peaceful stillness of the universe, a stillness that is full of wonder, of endless potential, and of endless love for all things. Here, in the quiet embrace of the cosmos, you are safe. You are protected by the vastness of the universe, where time and space bend and stretch, but where your journey remains gentle, soothing, and filled with peace. As you float, imagine passing through a black hole, not as something that pulls you toward destruction, but as a gateway to infinite realms. As you enter this black hole, you feel yourself gently pass through the event horizon, where time and space begin to feel different, where the rules of the universe relax, and where you are free to explore the endless possibilities that lie ahead. You are not in danger. You are safe, drifting peacefully through the soft, warm embrace of the infinite, with the gentle pull of the black hole guiding you into a new reality, one where every dream, every possibility, and every peaceful journey is yours to explore. Now, imagine you are floating in the center of a serene, tranquil universe, a universe free from fear and full of endless peace. You feel calm, your body completely relaxed, your mind free from the worries of the day. Here, time has no meaning. There is only the present, the peaceful present, where you are at one with the stars and the black holes that lead to new universes. All is calm, all is at peace. As you continue to relax deeper into this cosmic journey, allow the soothing rhythms of your breath to guide you into a state of deep, restorative sleep. The universe is vast, but in this moment, you are the center of it, floating peacefully among the stars, safe and serene. You are part of something far greater than you can fully comprehend, a universe full of infinite possibilities, where black holes are portals to infinite realms, and where every moment is filled with peace, safety, and endless serenity. As you sleep, let the mysteries of the cosmos continue to unfold in your dreams. Let the peaceful journey through black holes and parallel universes fill your mind, soothing you into a deep and restful sleep. In this cosmic expanse, you are protected, you are loved, and you are free to explore the infinite possibilities of the universe, all while resting in the calmest of spaces. Feel your body becoming heavier, your mind more peaceful with each passing second. Let the universe take you into its gentle embrace as you drift further into sleep. You are surrounded by the safety of the stars, the comforting embrace of the unknown, and the infinite journey that awaits, all while you rest. The journey through space continues, and you are at peace. Sleep now, peacefully and deeply, as the universe continues its eternal dance. You are part of it all, safe, serene, and at home among the stars.